Welcome to the project demonstration of solar wireless electrical vehicle charging system. So the main application of this project is, in order to charge our electrical vehicles, we need to do the normal conventional way of charger, connecting them to mechanically, but that is not safe always. So the solution, we come with wireless power transmission for charging of electrical vehicles. So in real time it can be implemented on road while we are driving on the particular specified designed road. Then we can charge electrical vehicle through wireless power transmission concept. That is totally contactless, and the power is going to be transmitted from one coil to another coil. So that coils are called as a primary coil and a secondary coil. So we use this kind of coils for power transmission as well as power receiving purpose. So the concept is wireless power transmission. To achieve this concept, we are going to use a main concept of theory concept of mutual induction. So that is when we mutual induction force, when we place two copper coils, one is induced EMF and one is a EMF based one, and when we place a secondary coil in the region of this EMF, then the secondary coil will get the induced, and so that we will get the same frequency based voltage, means wireless power transmitting from one coil to another coil based on this mutual induction concept. And for that, achieving that, we need to provide the high frequency signals to the copper coil. Then only the EMF will be generated around this copper coil. For that purpose, in this model we are achieving that concept with the help of nano board, as we totally made the customized thing. So here the power input to the system is two ways. One is a transformer to and another is a solar panel. Whenever the sunlight is not available, with the help of this grid power supply 230 volts AC input, we can charge this battery pack. So the main project run with the solar panel only. So while demonstrating the project, we should keep the battery under charging, and with the help of the solar panel, when we place this solar panel under the sunlight, then the power will be generated from this one, and it is the input to the battery pack. So here we are using the ratings of the solar panel is 12 volt 3 watt and the battery pack is 12 volt 1 amp, and through this charging circuits the battery will get charged, as well as we can charge a battery pack with the help of this transformer. Whenever the sunlight is not available, just connect the 230 volts AC input to this transformer. So the light indicated, as of now there is no sunlight on the solar panel, that's why there is no indication from this one. So if you get some external light here, we can see the light indication increases, means light intensity is increasing. So like that, when we place this kit under the full sunlight to the solar panel, then same brightness will be coming from this LED indication. So if you want to charge a battery either from solar panel or from the grid, means 230 volts AC input, it will take around 4 to 5 hours to be fully charged. Till the duration, we should keep the battery under charging. So if both are available, then only in 1.5 hour only we can charge a battery pack directly. So before demonstration, as we discussed, keep the battery under charging. The next, the flow is from solar panel, from the grid to the battery, and from the battery is a DC source, as we need to convert the DC to AC with required frequency. So in our project, we are converting the DC to AC of 120 kilohertz. That kind of frequency will be generated from this nano board, and from there to the MOSFET. The MOSFET will provide that input to this copper coil. So when we are providing the 120 kilohertz of AC signal 12 volts to this copper coil, then the EMF will be generated around this copper coil, and when we place this secondary coil in the same region, then that will be converted into the AC of 12 volts, and that will be converted into the DC with the help of this rectifier AC and filter capacitor, and that will be input to this DC load of LED indication, which will show the status of power is receiving at the car section, means AV vehicle section. Let us see the demonstration. As we discussed before, switch on the kit, we should keep the battery under full charge. Now on the power supply, the Arduino indicated, the kit got switched on. Whenever vehicle is moving on this copper coil region, there we get the light indication on this vehicle. Okay, so when the same aligned, then we'll get the maximum power, and bit high distance you can see the light intensity also on this maximum power. Right, if you have this also, then there is no indication. Right, in this manner, the wireless power transmission is useful for electrical vehicle charging system, which is safe and secure in many scenarios. Thank you.